Good morning, good afternoon, good evening, everyone around the world. Uh, this is the fourth episode of Talking with Titans webinar series that we started in June, about 5 months ago. We had September off because Albert and I both were attending InfoFish webinar, I guess. So welcome everyone on this platform. And as you know, the Aquaculture Nutritionists Network was established in 2011 with some few people, and Albert was kind of one of the few first that I convinced to join. And today we have 2,500 plus members from all over the world, and this is jointly organized with Jefo, and Jefo provided all necessary logistic supports, marketing and everything. And what Jefo is a global leader of, as you know, feed additives, animal feed additive supplier, non-medicated feed additive supplier. And the company was started about more than 38 years ago in a small town called Saint-Hyacinthe in Quebec by Mr. John Fontaine, who is an agrologist by training, with the mission that to help the people in need around his city, his town. People, I mean farmers, small farmers. And that's how we started. The company started. So today, as you know, our regular host panelist is Dr. Albert Tacon, who is like one of the icon in the world. I think he feels shy about it, but he is. And we have our special guest today, Professor Alan Davis from Auburn University. And I think I got to know about Auburn University, I think through Dr. Claude Boyd. I think he was, I was in Thailand at AIT 96, 97, and he was visiting us at the time. We had a small CRISP project, if I don't know, the PDA, Pond Dynamics Aquaculture CRISP project. And I was working that, that's what I got to know. I think Dr. Boyd and also Auburn. And I knew Alan's name for a long time, but I think we first met probably in 2015 in Mexico. It was, I think, a nutrition meeting in Mexico. That was the first meeting, and we did some work together at some point and some conversation as well. And I want to welcome Alan to this. I call it show, but we want to have open discussion about the today's topics and future topics as well. And I will ask Alan to talk about himself, his journey until today, and how he got interested into aquaculture nutrition. And just to add one more thing, he has his ex-students working all over the world. This is a tremendous achievement for someone, you know, in the industry for the last 20 years and in a good position, helping the industry to grow his students. Alan, your floor. Okay.
Thank you very much, Kabir and Albert. I appreciate the opportunity to be here, and I appreciate everybody taking the time to set in on this webinar and listen to me, and hopefully you won't be too bored and we might entertain you a little bit. But in terms of my background, not sure if you guys are familiar with the US, but I'm originally from Phoenix, Arizona. That's the middle of the desert. So water and fish are pretty scarce there. But I had a good interest in biology, went to the University of Northern Arizona, which is Flagstaff. And then I had a choice to go to school in California or to come to Texas. And basically I'd been to California, so I decided to go to Texas, and I drove 20 hours across a desert with no air conditioning. Once I got there, it didn't matter if I liked it, I wasn't driving back. But I had the opportunity to study with Ed Robinson, who is one of the founding nutritionists for catfish nutrition. Then work with Addison Lawrence, Delbert Gatlin. So some of the great nutritionists that have really contributed to the industry and were there from the start of aquaculture nutrition, especially Ed Robinson. Addison Lawrence. I worked for the University of Texas for some time and then went over to Alabama. So I've been in Alabama for about 20 years working for Auburn University and loving it. We have a great program here. We've graduated a lot of students. As Kabir said, I've got students from all over the world. They've just been a pleasure to have. And the reason I'm in aquaculture is because it's got a lot of different things. I kind of like puzzles. I kind of like building things. I like growing animals. I like seeing fish grow. Don't really like writing papers. Don't like writing proposals, but we all do it and we all manage it. But the real joy is actually having a lot of students, a lot of visiting scientists that come into my lab, a lot of friends around the world that we can share our ideas with and talk about the good and the bad things of the industry. And hopefully we've moved the industry along. But anyways, that's a little bit about my background, Kabir. Hopefully that covers the bases. You want me to go ahead and jump in the presentation then?
No. I have another question for you, right?
All
right. Sorry. So talk about like yourself, like what motivates you to do what you do, right? Every day, every morning you wake up, all right?
Well, I just love what I do, and I don't know how to describe it, but the way I say it is I like puzzles. I like figuring out how to get from one thing to another thing and how to put different things together to get it done, if that makes sense. We've built hundreds, literally, of research facilities over my career in terms of systems. We've changed systems because we want to improve, so I get to do design and plumbing. I like to find out that somebody else is wrong and I can put them right. I hate to say it, but a lot of my career has actually not been because we had planned research. It's because somebody said something was completely wrong and I felt it needed to be corrected. Or we had information that just frustrated me and we just beat on it till we got an answer that was reasonable. So, I just like working those problems. As I said, it's doing biology, it's doing, engineering, it's doing writing and putting people together. It's working, like with you on projects. We've had projects with Albert with projects to have something that we want to solve, and we try and put all the pieces together to figure out how best to solve that problem. And that's, what I like doing, is just putting those puzzles together, so to speak.
Wonderful. We'll just take 2 more minutes. I forgot to introduce Annie. Annie is a permanent fixture. Annie's NPA. She's the marketing guru in Jefo. And she's, I think, from the very beginning, she is with us, talking with us, except the last time she was on vacation in a quiet forest. She didn't know anything about, at that time, nothing about Jefo or anything, but very beautiful forest, I guess. So Annie is with us from the very beginning. Annie is with us as well today. I will ask Annie to, have some, take a minute or two for the housekeeping stuff that for all the audiences and us as well. Annie.
Okay. Thank you, Kabir. So my turn to welcome everybody here and thank you for being there. We're really happy to have you here with us for the first time or for another time. So today, actually, we're going to have a conversation for about 35 minutes, I think, about a presentation. And we're going to have an open discussion on the topic. So while we're having this discussion, we invite you to leave your question in the question box that we're going to be trying to answer over the conversation. If we're not able to answer them all, then don't worry. We will send you an answer by email after. Once this webinar is over, you can also get access to the recorded session on Talking with Titans webpage. I'm going to leave the link in the chat box, so in order for you to make sure you get access to it. And also, we've also let a copy of the presentation that we're going to be giving today. We let it in the handout, so feel free to download it. And if you have other questions, then you can just reply to the email you just received from GoToWebinar system, and we will be pleased to answer you. So thank you very much, and have a great conversation.
Thank you so much, Annie, for the housekeeping. Without you, we are dead. That's what's saying. But I will let Alan take over, right, for the presentation, and we will we will go dark, I think, for the next 35 minutes. Alan, this is your floor, and we will learn about the research methods, right, and the problems. Thank you, Alan.
All right. So hopefully I've got this right, and you should now have full screen my presentation. Is that right, Albert?
We do.
Yep, perfect.
Yeah.
All right, so, you know, I gave you a nice introduction in terms of my education. I'll give you a little bit different in terms of comparison of what competencies you might say. I like to make fun of myself and other people. So, you know, I've put in a lot of journal articles, and I've pretty much been rejected by about every journal that I've ever published in. I've also been rejected by every granting agency. So even though that, you know, saying that, we've got, and this is not me, this is my laboratory. We have over 200 peer-reviewed publications in aquaculture, nutrition, and production. We've managed over $15 million in funding. So some people might say that would be a modest career, but I think that's a pretty good line of what we've been doing. And what I find kind of interesting, if you look at, these are paraphrases out of some of the grants and proposals that we put forward, is that, for example, no testable hypothesis. Well, it was stated in the grant very clearly. We've had people complain that we were using a standard research approach, and then they went on to complain that there was lack of experimental design, performance metrics, key statistics, approaches that address the hypotheses. Well, if it's a standard method that you just pointed out, all of those things are in a standard method. So it's a little bit interesting there. We've had people say there was a lack of novelty and what should be done by commodity or regional groups. Yet industrial funding relative to government funding is still relatively small. We see a lot more funding coming from the industry, and that's a good thing. But quite often that funding is fairly proprietary depending on where they are in their R&D. Or if we're talking farmers, and we do a lot of work with farmers, outreach is one of our strong suits. The problem with farmers is they want you to solve the problem of today, not the long-term problem that the industry faces. And so quite often it's difficult to get good things done at the farm level. And then my favorite was I had a grant that a commercial group came to us, wanted help with a research idea, and we developed it. We put it in as a proposal, and the reviewers said that there was no commercial application. Yet this was research proposed and mostly done on a commercial facility to solve industry problems. And what I find, you know, that's kind of interesting about all of this is research and techniques are based on perspective, okay? I don't have the answers because everything is my perspective and you have a very different perspective. One of the examples I use in my classes was this photo on the left. Now, this photo wasn't taken on purpose to be arbitrary, but it turned out to be so. If you look at the two photos on the right, different people see the photo on the left differently. I see the photo on the left as black and blue. Other people see it as gold and white. This isn't because the photo is one color or the other. The difference is your ability to perceive color. And this photo just happens to be right on that line where some people view it one way and other people view it the other way. And there's lots of examples of this, but it shows that our perceptions are not necessarily reality, and we need to think about what are other people thinking about. My favorite example for research people is, you know, I get data like this. Here's my 4 means. I got an R squared, which means, you know, 96% agreement that this is great data. This is the answer. Well, if you actually look at that data and look at the actual data, the R squared is only 42. So it's really saying 50% of the time I understand this, and the other rest of the time I really don't know if it's right. So, you know, this is perception. Do you look at a mean? Do you look at the actual data? Or do you think about the data as, well, maybe it's more than what I designed. Maybe there's other things going on, and maybe I shouldn't have designed it this way. You know, this data has 4 replicates and 4 treatments, so there's 16 data points. Well, maybe I should have been using 2 replicates and 8 treatments so that I can see more of the holistically what's going on. It just depends on what you want to do with the data and what you're looking for, but you got to design an experiment appropriately, and you got to make sure that your analyses is also appropriate, and realize there's not always one right answer. This is an example of real data from a taurine experiment, and the type of line is very distinctive. The problem is that there's 2 or 3 different models that actually can use to describe that line. And if you use one model, you get a slightly different answer than the other model. So again, statistically, you can argue either of these models being correct. Really what it is it's a choice of my perception of which one's a better model. So again, making sure that we understand the response and making sure we have appropriate analysis. So I see people talking about data all the time and not understanding what their data is really saying and what the biological response is. You know, for example, if you're looking for the highest point on a peak, well, maybe you got almost to that summit and then it started going down. So you said, hey, I'm done, I'm to the top. But when the clouds clear, maybe you're not even close to the top. Or maybe it's a plateau that you're running along and all of a sudden you come off a cliff. What is the response that you expect? And does that data show it? You know, and how do you look at it? We also have these interesting things where we oftentimes make correlations that maybe are not quite correct. You know, perceived data interpretation. Is it relevant or is it irrelevant? I love this graph because it's clear that if you look at global warming and the number of pirates that have been found in the waters of the world, as the pirate numbers went down, global warming went up. So the solution to global warming is just train more pirates, right? It's a spurious correlation. It's not a true correlation that has a meaning. And quite often in research, people don't come up with correct answers, and we need to make sure we do. So to me, research shouldn't be that hard. I have a lovely younger daughter who spend time with, and unfortunately that means I get to watch some cartoons. And I realized not too long ago that the scientific method is actually being taught in the 1st grade. And if you watch cartoons, there's actually some great cartoons that teach you the scientific method. And there's a cartoon, that they went through the scientific method and they actually had songs and things that described it. Yet when I go out into my classroom and ask what the scientific method is, quite often I have college students and PhD and master's students who look at me blankly and say, well, I know it's something, but I really can't describe it. So, our education system maybe is failing somewhere along the lines. I don't know. But let's just, talk briefly of, what the scientific method is. And it's just a few simple steps. You make an observation. You review the literature. Now, when I say you review the literature, does that mean you go to Google? Maybe. It means that you need to have an understanding of what the literature is around the topic that you're talking about. Doesn't mean that you have to go spend a month in a library or you have to be the world's expert. It just means you need to have an understanding of what that topic is and what has and has not been done. And then you're going to conduct some sort of experiment or research. You're going to analyze the results. And then what people quite often forget is maybe you go back all the way to the beginning because you don't have the information quite right. All right. So it's a process. It's a pretty simple process. Process that I'm really fond of is what you do in industry, what you do in business, because as far as I'm concerned, research is no different than business. In business, you're in the continual improvement process. If you don't continually improve a business, you go out of business. Well, if you look at research, it's a continual improvement process. We need to continually look at what we're doing, why we're doing it, and what the outcomes are, so we can improve that process. If you don't do your homework, right, you can't do anything correctly. We need to look and plan our research, design it based on outcomes. What are the probable outcomes that I'm going to have? And can I change the design to improve the outcomes or make them more likely to give me clear results? You got to do your homework to do that. If you're in business and you decide to change a process, which you think is going to make you more money, you do your homework. You look at it, You study it, you collect data on it, and then you make the change. Or you make the change and follow what the results are. But you got to do your homework because you're going to lose money. Well, if you don't do your homework, you're going to lose data or you're going to lose results, right? So has the work been done? Have the methods been established? You don't need to recreate methods or systems. Look around, see what's been done, right? How many levels do you need? And what levels do you need? Do you need just two things, a yes and a no, or do you need a bunch of levels to get a dose response, okay? It appears that a lot of people, when they're looking at research, don't really consider previous work or expected outcomes. So when I'm looking at research, when we're designing projects, we look at what we think the outcomes will be, and we actually look at what we think the outcomes won't be, because you want to design a project to answer both sides of a question, not just what you think is going to happen. You also have to look at what might not happen. So planning to me is very important. Designing a suitable experiment, thinking about statistical analysis, or how are you going to make differences? You know, are there different species, different conditions? Are there different genetic lines? If you're in production, maybe you're looking at different hatcheries to see if the performance is better in one hatchery or another hatchery. Well, you need to control the conditions and make sure that all the animals are from that specific hatchery and the conditions are similar. You know, whatever it is you're looking at, you need to look at what are the appropriate conditions and what are the methods. What do you want to do? Do you want to grow them in a pond? Do you want to grow them in an aquarium? And then, of course, what data is important to you? From a research standpoint on nutrition, I probably want growth and tissue deposition and some sort of biological measures. But if you're looking at a farm production system or a feed cost, maybe it's the time to market, maybe it's the economic return. But what data do you need to justify you getting good results or getting bad results, okay? And of course, we also always talk about a plan A, a plan B, a plan C, and quite often we're on plan Z. But you need to think about what is going to potentially go wrong and how am I going to deal with it? What are the good results, the bad results, and the probable issues that I'm going to have? What happens if I have diseases? What am I going to do in terms of preventing those? Appropriate systems. I'm a big proponent of making sure your systems are appropriate. How many replicates do you need? How many numbers of animals? This outhouse is an example from Texas A&M. That's where I went to school. They're great engineers, and you can see that they've designed that. So you can see that you got a lock on the outside and you got toilet paper that you can tell whether or not it's full or not before you go in there to use it. I don't think that thought that design out very far in terms of how to use that, all right? When we're designing research, we need to think about what's happening, what are the uses, and how are we going to do things, all right? If you're going to have animals, you know, do you need them for biochemistry? Do you need them for gene expression? Do you need them for a disease challenge? There's a huge difference in having the number of animals for a disease challenge or simply getting a tissue sample for some sort of analysis, okay? What are the production outcomes, or what are the outcomes that I need to look for? And we need to plan that into the experiment from the beginning, not think about it at the end, which quite often happens. In terms of replicates, you know, quite often people say 3 replicates or 30 individuals, or if you're talking about ponds, you probably need more like 5 ponds, 4 or 5 or even more. But what happens when you change the number of replicates? Now, this graph on the left is an exaggeration. If you look at that, that's a standard error of the mean, and I've made it much bigger than it actually looks. To have a difference of 0.5 is really not that big a difference. But you can see as you go from 4 to 7 to 10 to 15 that the standard error decreases. So if you can afford to have more and more replicates, you're probably going to get more clear results of what's going on. The problem is each one of those replicates costs you money. If you're a commercial producer with a 10-hectare pond, having 4 10-hectare ponds in a treatment may be extremely expensive. Now, the question you got to ask yourself is the cost benefit. If I don't find an answer, what's it going to cost me? You know, if I fail to find an answer when there really was a difference, okay? But you have to look at costs. How many replicates are reasonable? What are the resources out there? But in general, the more replication you can have, the better off you're going to be. Excuse me. Now, there's also, systems must be appropriate. And again, you need to think about the system that you're using, how big it is, how big the animals are. And quite often, you need to think about the size of the animals when you're done with your work. People oftentimes think about the start of an experiment or growth trial, but they don't think about the loading at the end. What's the biomass at the end of the trial? Is it like the big fish in the little boil? You may not have enough biomass or enough water to keep the water quality, keep the growth rates, because you've overshot your system's carrying capacity. There's also problems, with stocking densities. And we've done this with a lot of different species, and every species is going to be different. So this is not dogma. But if you look at shrimp, and we've done this in ponds, we've done this in outdoor tanks, we've done this in aquariums. This data is aquariums. And you see the same response in commercial situation. But as you increase density, growth rate decreases. So you have a choice. You can have more animals, which may relate better to the industry, or you can have less animals growing faster, which means I have more tissue replacement. The animal's growing faster. Excuse me. So, you make your choice. Do you have more animals, or do you have faster growth? Other things you may have they may be real or they may be imaginary. So on the graph on the bottom, we have the coefficient of individuals within replicates. And this is from the same experiment. And what's interesting is the variation went up as we stocked more animals. Now when we see this, you can either say, well, this is because density caused that, or you can say, hey, maybe it's not because density caused that. Maybe that's actually us causing a problem. And if you think about it, that's probably the issue. It's not the animals having higher variation. If you go and size sort, let's say 20 animals, it's easy to size sort to a uniform size. Now do that for 100 animals. You're going to find that you're going to have some that are big and some that are small, which means the coefficient of variation went up. So we think this is due to our technique, not the response of the animals. But when you collect data, you have to make that decision. Is this something I induced, or is this something a response from the animals? Different species get different responses. Example with tilapia. We do a lot of work with tilapia. This is an example of thermal growth coefficient. So it standardizes the responses. But we looked at low density and high density. I apologize. This is the joy of live, is you get all the good and the bad. But at low density, the coefficient of variation is much higher. So the population within an aquarium, as well as the differences between aquariums or tanks or systems, when you go to high density, you get less variation. Why is that? Well, in tilapia, there is a hierarchy, a social structure. And if you're at low density, your social structure is allowed to occur. And you have big animals and you have small animals. But if you crowd them together, you break down the social structure. You get much more uniformity of your animals. So again, it's a different response for different species. What I tell my students is pick your poison and pick it carefully. Maybe it's very toxic, or maybe it's not so toxic, but you have to make a choice of what you're going to do in terms of densities, in terms of number stocking. There's always an advantage, there's always a disadvantage. Now, I'm a big proponent of either designing a system or choosing a system for the research you want to do. There's lots of systems out there. We're blessed with having lots of resources. We have over 300 ponds at our facility. We probably have around 1,000 tanks of varying sizes. So we can go in and we purposely have a range of different types of systems, so you can go to a system that most fits your research and then design around that particular system, or we simply build a system for the particular research we're doing. And what's interesting, a lot of people think that research systems are expensive. We've put a lot of research systems on farms to allow us to answer questions on the farm and allow the farmer to see the response that's occurring without having to invest in full pond production type systems. And they're really not that expensive to put in. literally a 5-gallon bucket can be a replicate, or a tank, which is only maybe $150. They're not that expensive to put in. We've done it a lot of different systems, and not all systems work. We do a little bit of work with feeding behavior, and this is an example where we don't do a lot of work with feeding behavior, and the reason we don't do it is we don't like the systems that people do feeding behavior in. We've not had very good results in terms of very labor intensive, very difficult to get consistent results, but so we've gone to a different technique. We've started looking at passive acoustic monitoring as an alternative to what is traditionally used to look at attractants and feed management and other things. And by using, for shrimp, they actually make a little clicking behavior. When they consume feed, they make a click. And so it's very quantifiable, and it's correlated with intake or the quantity of feed that's consumed. So we've been able to take this and look at different parameters, but this is a non-invasive, very precise way that you can measure singularly or in groups, and without even having to see the animals, what they're doing. And so this is a very unique mechanism to try and look at behaviors and look at feed intake in shrimp, at least. It doesn't work for fish because they don't necessarily make a noise, but it works great for shrimp. So again, looking for a technology that might be applicable for what your problem is, because it may not be typically used in research, and you may have to get it from somewhere else. So this is some of the things that we're working with. We also have to look at, what kind of data are you going to collect? If you don't have proper descriptive data, you're not going to get the job done. It's very critical. How will you collect it? The frequency and the precision. How are you going to review that data? Remember, people make mistakes when they're recording data. You have anomalies, you have errors, you have things that happen. Maybe, something happened that an aerator failed and half the fish died in the pond. Does that mean it's representative of what's going on? No. You need to have standards for looking at that data. And then you need to report what is important. I mean, we can put out, huge graphs and figures, but if they don't have any importance, why are we doing that? What data do you really need, whether or not it's growth, enzymatic, biochemical, economic, and then you're going to have to archive all that data and make sure it's available. If you don't take care of your data, and I can go back 30 years in my data, and we can pretty much open it up and figure out what was going on, and it's not much different in terms of how it was categorized and stored compared to what we're doing today. We have spent a lot of time thinking about how we want to store our data, because if I can't look back at it and use it sometime in the future, it's really not that good. You in business, if you're running a business, you look back at your financials and you predict your future. Well, you need to be able to do that with your data from research. You may want to go back and check things out. We're a little bit slow. So, quantity and quality of data, do you have to make a table like this to get a point across? I don't think we do. This is just a bunch of numbers that really have very little meaning. We also need to make sure that when we're talking about things that we have valid comparisons. Yes, we're comparing, 188 calories on the picture on the left. We're comparing fruit on the picture on the right. But if we're talking about apples and different kinds of apples, why is there an orange in there? Quite often when we're looking at things, there's inappropriate comparisons, or maybe there's just a different perspective on why you should use that comparison. Now, you can compare very different things, and we quite often do it, but you got to also understand that maybe that's not the best comparison. The most common example in nutrition is everything is compared against fish meal. Well, actually, most things aren't good comparisons against fish meal. If you look at a plant-based protein, it doesn't have a lot of the things that fish meal has. Therefore, it's really not that good a comparison with fish meal. Now, you can make that comparison, but you need to make sure that the nutritional is balanced for all the components that are missing in that plant-based ingredient when you're making that comparison. So be careful what you're making your comparisons about. Now, how people organize data, that's what resources they have. I'm lucky here at the university, we use SharePoint because I'm a believer that I want to have access to my data anywhere I'm in the world. I travel all over the world, and I'll have people ask me about data, and guess what? I can get on any computer anywhere in the world and I can pull up data from any study that we have, because we have it organized and we have it web-based, and it's accessible and it's secure. There's databases, there's lots of different ways to store data, but you need to think about collecting that data and keeping it in some sort of order. For my research projects, we happen to use chronological. We use dates. We put major categories. So for example, data, papers, presentations, and then everything is done by year. And for our experiments, we have coding for that. So I can look back and find any experiment that I ran throughout my career, because I actually have an Excel spreadsheet that lists them all. So I can find anything that I want. But you had to think about that in order to have that well organized. Now, organization to me is very important no matter what you're doing. If you're running a business, if you're running research, whatever. We work on standard operating procedures. It's critical for maintaining animals. It's critical for running any sort of operation, in my opinion. If you're a business, you have standard operating procedures. If you're doing research, if you're a farm, you should have standard operating procedures, because it is a business. As an example, as I said, we have 300 ponds on this facility. My group is managing anywhere from 10 to 20 systems, somewhere around 600 independent aquariums, and somewhere between 16 and 36 ponds at any given point in time. Right now, we're down to 12 raceways in a pond in terms of our outdoor systems, because we've harvested a lot of our ponds. But it's critical that you organize standard operating procedures and make those procedures very easy for people. One of the things that a little bit unique in our lab, picture on the left shows it, I hate numbering things. When I originally went to school, we put a number on every test tube that we used, and that corresponded to some treatment. And then you ran your next experiment, and so you renumbered all your test tubes and wrote the treatments on them again. Well, we use positional things for all the biochemistry we do. We use positional for our treatments. So if you look on the left, I've got one of our aquariums being fed, and you can see there's different colors. Those correspond to a treatment. So we simply assign a treatment to a color and realize that that yellow or orange that's in number 5 spot, well, next experiment, it might be in number 12 or number 1. I don't want to renumber everything. We simply just change things positionally, because that saves us time. It makes it easier on my people in terms of setting up an experiment and changing things. If you have to renumber everything every time, you're going to stop doing that. You're going to stop randomly moving things around. So make things simple. There's lots of standard operating procedures that make things simplified, make things as easy on your people as you can. Quite often people ask me, how long should I run a nutrition trial? I don't have an answer. As far as I'm concerned, time is irrelevant. It's not part of the question. Now, reality is, yes, it is in there. But what we're looking at in nutrition trials is we're looking at tissue replacement. That's what's important. So how long does it take to get the tissue replacement that you need to induce whatever you're looking at? Now, you do want high level of tissue replacement, but you also realize the longer you run a trial, the more risks you have. You might have disease occurrences. You might have just random events that lose your animals. You might also have the fact that as you run a trial longer, the variation might actually get bigger. So you need to understand what the constraints are and make decisions based on what's going on. As an example, if you're dealing with a larval fish that has a 12-day cycle, and you want to look at first feeding larval feeds, would you run a 56-day trial and try and interpret the results? No. You'd run a 12-day trial, because that's in the larval cycle. So it's not a daytime. Maybe it's, you looking at days to market. Maybe that's your measure, but the days to market on every crop is not the same. It's going to be similar, but temperature, genetics, lots of things change the number of days to market. So you got to be flexible. You just have a range of what you're looking for. But for us in nutrition, it's usually typically it's tissue replacement, and usually the more tissue replacement that you're going to do, the better off you are. But for example, if you're doing broodstock, you're not looking at tissue replacement, you're looking at eggs and fry. So different things depending on what you're going to do. Make sure it's long enough to demonstrate what it is you're looking at demonstrating. And when you're creating data, when you're writing up data, whenever you're dealing with these things, you got to make sure that you make it clear. You know, if you're describing a diet, you got to be specific. Define the basal, define the final levels. Quite often people talk about supplements. Well, a requirement is not a supplement. A requirement is a total level, all right? So we need to not say I supplemented X amount. We need to say the basal diet has this, I supplemented this, the total is this. It needs to be well labeled because you may want to come back to it later on, or you change the diet, in which case just saying what the supplement is doesn't make any sense. What is the level in the diet? What are the terms that we're using? Are you talking about total sulfur amino acids, or are you talking about methionine? Because those are two different things. You know, I have terms that are used improperly all the time. I starved my fish for 1 week or 24 hours. Well, starved means you did harm to your animal, essentially. What you did was you fasted them, right? My favorite term, which I still don't know what it means, is significant resemblance. I don't know what it used, but it was actually in a publication that they had significant resemblance. Anyways, there's lots of terms that aren't clear. Make sure you're using proper terms, not only in labeling things, collecting data, when you give that to your people that you're talking about. Again, tables, figures, you want to make sure that you have them proper with the abbreviations, that what is going on in terms of the tests, what kind of statistics, what kind of variables are you looking at? What are the clear definitions? And then I also get questions about processing feeds, and we have discussions on this, and no, I don't have an answer. Quite often people say if you're going to do a nutrition trial, it's worthless unless it's commercially processed. Well, there are processing that will have effects on performance of animals. I do not disagree with that. But we have taken the same feed. We've done this with catfish, we've done this with shrimp, we've done this with tilapia also, I believe, where we took a mash, a mixture of feed, and we pelleted it in the laboratory. We pelleted it in a pellet mill. We extruded it under extrusion conditions. We've extruded under laboratory conditions, you know, a very small extruder. And we ran those diets, different times, different species. And guess what? They pretty much did the same performance. Now, don't get me wrong. If you're looking at, for example, let's say corn, which is hard to gelatinize, and we're looking at the gelatinization and the effect on the animals, if I do a lab-based feed or a truly extruded feed, yeah, you're going to get differences in results because the extruded feed is going to have a lot higher gelatinization. But if I can equal the gelatinization, then they're going to be the same. So there are stability differences, there's sinking and floating differences. There are differences between all the ways that people produce feeds to do research. But to be honest, not one of them is better than the other, and quite often they don't give different results. Quite often I have people talking about needing to have a reference diet, whether or not it's a commercial diet that's in reference to research or in a trial. And as far as I'm concerned, benchmarking is good. That's a good thing. But for example, this year we've ran over 40 trials. That would be 40 treatments that I wasted if I had to put a reference diet in every one of my experiments. Reference diets are good. They should be there every once in a while, but they're, in my opinion, you know, pretty much a waste of space where I could be using something to figure something out. Now, occasionally we do run reference diets. We run commercial diet every once in a while with our research diets to confirm that we're in the same performance as they are, but to do it all the time is just not real appropriate in my book. Now, from an academic standpoint, we want to publish. I ran an experiment, realized just because you ran it doesn't mean it's good. Not all experiments give good results. There's reasons to have issues. The data must be repeatable. I'm a proponent of, I want to see more than one trial to give a result. Now, it might be preliminary data and then a true data, but I want some sort of validation in time before we start trying to promote something or publish things. I want to see it multiple times. And not all data is worth publishing. You know, maybe it's preliminary data, maybe it's a way to improve our next trial, or maybe it's simply junk and you just need to throw it out. But we have a tendency that, at least in the academic field to want to publish everything, and the reality is a lot of it is not worth publishing, and we don't need to go there. To me, there's another issue that we've talked about recently, at least within my lab, is publishing versus communication. Right now, I think we're doing a good job of communicating, okay? I'm pretty sure that you guys out there haven't gone and read all my papers, all right? But hopefully, you've maybe seen one of my talks. Maybe you've seen a YouTube video that Auburn University has done in terms of aquaculture, or one that I've done on nutrition, or maybe you've heard me at a meeting talk on whatever subject I'm talking on. To me, the industry needs the communication. Yeah, publishing papers is great, and that's what keeps my job. But reality is communication with you in the industry is what keeps the industry moving and gives you the information that I think you need, whether or not this talk is good information, helpful information or not, but I think it's pretty good communication, or at least we hope it is. So, you know, what's the difference between a read versus a click? A YouTube video like this, which I think is very helpful to the industry because it gives a nice dialogue between people. Now, in terms of, you know, time, I think I'm pretty much end of my tale. I just want to summarize a few things that, you know, I'm opposed to standardized research. We have lots of discussions on that. You know why? Because I want to improve. No one method is best. People have different resources, so use them wisely. It doesn't take a high-tech system to get good results. It takes good planning, good management to get good results. To me, cookie cutter, you know, techniques limit creative methodologies. If somebody wants to be creative, you know, we didn't go out thinking that acoustics would be a great way to look at intake for shrimp. We happened to stumble into that, and we had an open enough mind to start evaluating and seeing if it's there. It wasn't a standard thing. So if you're not open to change, you're not going to find it. So what I'm in favor of is standard operating procedures, critical review of processes to improve them. Research is just like a business. You want to improve it, and you want to be in it for the long run. We want to make sure you have an impact. And to me, the biggest thing, or biggest complaint I have about people is that we need to think about outcomes prior to acting. If I go and do X, what are the results down the line of me doing that? Will I get the outcomes I want? Or if it goes the wrong way, can I interpret what's going on? But thinking about what my current action is, or what I plan to do, and what the results are going to be down the road. And with that, I'll thank you for giving me a little bit of time, and I'll come back to Kabir and Albert. So hopefully we can have some good discussion on the value of research, both in the laboratory and out on the farm or in industry. Appreciate everybody's time. And
thank you. Yep. Thank you, Alan. I think we are waiting for Albert to join, but yes, we do have. It was a very, I think, useful presentation to know. I think to crack the black box that we have in terms of research, and when it is black, we are always afraid of doing research, right? I think a lot of people in the industry are really afraid of you know, stepping into that. Okay, we have to do research, like what to do and how to do, when to do, and people think it's very costly, right? Also, it's about, I think, that fear of that we rely on mostly supplier like us, right, in the industry, that to giving that knowledge and information of a product. So the one question was, right, you talked about the importance of the background research, right? The review of literature.
People take that different ways. You know, in an academic setting, you need to do your homework and understand what's going on. But when we say we need to understand the background, if I'm a commercial producer, right, and I want to evaluate a product, or, you know, it doesn't matter if it's genetic lines or it's a supplement or it's a different commercial feed, you need to understand how to do that. You need to understand what other people have done in that arena and how they've evaluated it. So it's not so much that, if I'm looking at we'll be more specific, a methionine supplement. Do I need to know everything about, every supplement, every species that has had methionine? No, but I should have an understanding of where the methionine requirement is and how people have judged it. If you're doing research on an academic scale, that bar is probably a lot higher than if you're doing it on a commercial basis. But you do have to have a working knowledge, and quite often I get people who jump into something without a working knowledge.
So coming to the specific situations, like say a small farmer with one or two ponds and wants to test two different feeds, right? Like,
yeah. Well, the thing is that in some cases, and I've made a lot of people mad over my lifetime, in that, if you only have one of something, you're never going to be able to make a decision. The way I kind of look at it is, if you're going to go buy a car, you wouldn't go look at one car and just ask, is this a good car? It is. I'll buy it. Leave. You go and do research, and you're going to go set in more than one car to make that comparison. If you want to, look at improving your business, you have to have real answers. And the reality is that, animals are variable, ponds are variable. I can go out, to our facility, and there's a good probability that I probably find a pond or two that probably will not perform, and I can find a pond or two that always perform. I can select them to get the results I want. Right. So we just need to look at the resources that we have. If you have very limited resources, what we quite often do is we'll put small tanks and pump water from a pond, or we'll put cages. There's different things that can be done to try and get at that in a better scientific way. But I like small tanks on the side of a bank where we can pump water through it, and you have water exchange. Doesn't cost a lot to install it. There's a little bit of cost, don't get me wrong, but you can get some very nice results out of those within the constraints. But when we go to, a single, and this happens all the time. I have worked with farms that have literally thousands of ponds. So you can't say that the number is restrictive, yet they still don't do a good job of trying to make fair comparisons.
Right.
Because there's stocking differences, there's genetic lines, there's managers, there's, and so all you got to do is make sure that you have as best the comparison as you can in the situation that you have, and use it to the best of your ability. But I really don't think when we're dealing with single units that it's a good measure.
Right.
When I bought my car, I didn't look at a single car.
Right. You decided to go for that one or that model, and then done. Right?
Yeah.
Something like that.
And even when I decided to get that model, I went to multiple groups to find out where I could get the best price.
Right.
If I'm a business, and aquaculture is business, I'm sorry. The job is to improve my business. If I want to improve my business, that's a stepwise process. You can call it business evaluation, or you can call it research. But the reality is research to improve production is no different than research to improve performance at a factory or a job.
So Albert is back, having some technical difficulties, right?
Welcome back, Albert. We've solved all of the world's problems.
Yeah, we did. So the question was basically
on farm type of research, and the fact that I'm a proponent of doing the best with what you can have, but you need to plan it. You need to, it's a business. You need to improve it. You can't do that on a pond of one or an N of one. You have to have replication. You have to have controls. So I think, one of the issues with the industry is that, there are quite a few university-based research systems, but there's not a lot of industry-based research facilities, and that is one thing that the industry, I think, is lacking.
The fear is cost and expertise, right? So that's the kind of discussion we are trying to have, like to have people more idea and get out of that fear of doing good research, right? We have to be perfect. No, we cannot be perfect all the time.
No.
Right? So that's.
I mean, to me, the issue is, as I said, I mean, I hate to harp on it, but aquaculture is a business. And if you want to run a business, you have to understand what changes give you better returns on your investment or performance or whatever measure you want to use. And in order to do that, you have to have systematic evaluation. You can call it improving a business or you can call it research, but you have to make that systematic comparison that's fair to make a decision. And so I think that research and business improvement go hand in hand, and they're critical to make a stepwise improvements. I see people making changes on whole farms all the time without demonstrating that there was actual economic value in doing it.
Your opinion, Albert, on this?
Can you hear me now?
Yes, please.
Okay.
Go ahead.
No, like I've said many times before, I mean, for the farmer, 40 to 60% of his or her operating costs is feeds and feeding. So a good farmer, if he or she is smart, is to have a part of the farm where he can think or she can think about tomorrow, where, okay, maybe you cannot have so many ponds, but you can put cages within ponds, depending on the species that you're growing, where you can test different feeds, whether it's competitive feeds, whether it's, you know, so like Alan, I mean, Alan is easily probably one of the most, you know, currently the best R&D researcher in shrimp on the planet. But one of the beautiful things about his work is that not only does he do work in aquarium, in tanks, but also he does trials in ponds.
Right.
And at the end of the day, you know, to change a farmer perspective on certain things, you have to really show, you know, so I'm a big proponent of on-farm research, which sometimes is a lot cheaper than actually doing it yourself, because you actually do it with the farmer, and at the end of the day, the farmer applies the results if it works, you know. And so again, so it was just really saying that even though we have a few ponds, you know, we can do a lot with those ponds.
Yeah, and I agree with you, Albert. The, you know, demonstration-based research on the farm is one of the great ways to transfer technology and to help the farmer improve his facilities. And I'm also cages and tanks, and if they're willing to invest in, you know, their ponds, that's even better, depending on what their resources are. The caution that we always, or issues that you do run into, is the farmer may change midstream if it's an entire pond, because he thinks he's going to lose money or potentially lose money. But I'd argue that he's going to lose more money not finding out what the right outcome is. Not to say that if you have an issue, you need to correct it. But the biggest problem with, you know, large on-farm research is having them standardize and do it. But clearly that's an advantage, and it's to make them more money in the future. You know, I contend that there's probably more money to be made in feed management than there is optimizing the nutrition. That depends on the species that you're talking about. If you're talking salmon, then it's more nutrition than feed management. But in a lot of species, feed management, there's actually more to be made for proper feed management.
Following up with this one, there are two questions. Sorry, Albert, you can go ahead.
No. I was just going to, repeat what Alan said. I mean, my passion, like Alan, is research, R&D. I like it when things go wrong, and then our job is to try and come up with solutions to address those problems. You know, what's the point of knowing all the things that we know about nutrition and feeds if we don't apply them? And so that's the fun part of our job, and that's why it's it's a passion and we enjoy it so much, rather than take it as a 9-to-5 job.
Right. So the follow-up questions to this is like in terms of research, right? We have an idea and then concept, and then we try to prove that concept in small laboratory scale, and then try to commercialize that concept if it is proven in the laboratory. Before, I would say 20, 30 years ago, it could take 10, 20 years from an idea to be commercialized from university laboratory to university, from university to the field or to the public. But today, I think integration with the commercial industry and academia, I think much stronger. That ideas could be commercialized much faster than before. But do you think, what are the positives and negatives of this, right? And I think it happened because there were the funding from the public sources went down. I think in the last 15, 20 years, universities has to look for funding from private entities more. Is there any good, like we know the goods, and what are the bads, or what are the goods of this? I just want to have a discussion on that area.
Well, to me, you can make the argument, and I mean, I do a lot of commodity research and a lot of private research as well as government research. Government research by far is more money, as long as you can get it. But I think to me, the drive for actually doing commercial research or working with commercial companies is that you're helping drive the products that are going out there, that you're part of that solution. Most government projects are more on the way back here. They don't get applied real soon. So I think that there has been an interest of commercial companies coming to universities or research organizations or moving things forward. And I think that things do get moved forward quicker in many cases because of the ties or the expertise. But also there's just a need to do that, that you need to get to market much quicker these days in order to capture the dollars in sales and be the first in the market, or not necessarily the most early adapter. But you need to be in the market and establish that market, capture it market. So you do want to move quickly. But I mean, we've seen products, some fail, some do well, where we'll start with an R&D from a company, and within several years, they'll have a new product on the market. So it can move very quickly depending on what the regulations. But I think a lot of it is demonstrating regulations also. Getting, you sell in multiple countries, you have to be registered in those countries. So it's not just meeting the R&D requirement, it's also meeting the requirements to actually sell a product in any given country, some of which are very slow.
Right. Albert?
No, my only comment would be to give the example of Norway, where the government really invests a lot of money into R&D to support the aquaculture sector. And basically, one or two species, whether it's Atlantic salmon, Arctic char, or Atlantic cod. In aquaculture, we have over 214 different fed species. And in some countries, what limited resources we have, they're spread over many different species. And the trend in many countries, including the UK, where I worked before, is to close these government institutions, which is a real shame. But all I'm just saying is that we need government research, but also we need university research. And then, the private sector has its own research. But I think government is important because in the end, government are the ones that set the rules and regulations for our sector regarding feed manufacture, fish quality, and other aspects. So it's really, really important that they keep a handle on that. So that's really my only comment.
And the countries that invest a lot in R&D move things ahead much quicker than those that don't. So whether or not it's government, industry, or private sector, but development is driven by people spending money and being creative. You know, what I don't like is when, I mean, you've got some examples of fantastic ways of spending money for, I mean, the European Union has gone into some very huge project to solve some very difficult species, working with eel, or, you know, you got projects working with tuna, where the quantity of money required to really break those animals is huge, and you need to have multiple people with very creative thought process and lots of money working on things. So I think it takes a mixture of dollars and creativity, but we don't want to get, you don't want to stifle the creativity and just go down one road in terms of who does research.
There was a question next question from Zurida, if you know, Zurida, just about having positive and negative control, right? How important is it? You have a slide there.
Well, I mean, we can argue over that all night. And first, you got to define a positive and a negative control.
What does it mean?
I mean, I can feed dirt and have a negative control.
Right.
It depends on what you're trying to do. You're looking for a response, and what do you want to measure within that response?
Right.
My problem with having a, you know, quote unquote positive and negative control is I don't know what they mean, first of all, and I just wasted two of my treatments, and now I can't describe my response any better or less. So in certain times, it's very helpful to have, but other times it's just not very appropriate in my mind. And so people have this tendency to say, this is the way it's done, and that's wrong. It depends on what your output is. If I want to judge simply a yes or no question, well, I need a positive and a negative. And then where am I relative to that?
Right.
So I don't know, Albert can.
Albert can.
No, I agree with Alan. At the end of the day, it all depends on the aim of the experiment and what you want to show or not.
Right.
You know, so it's depends on the study and what you want to do.
Can I go to the next question? It is about extruded and pelleted feed, right? Say for a feeding trial, as you discussed about this as well, right? Gelatinization, other things. But besides that, with my experience, right, with the commercial extruded feed, and then I pelleted the feed, and there was no difference, and up until 12 weeks. After 12 weeks, there was some differences, and when you analyze the feed, the extruded feed had high protein level, 3% higher protein, good protein level. But in terms of growth, first 12 weeks, there was no difference. So to me, what I felt is like we have to make sure that all pellets are eaten by the animal. That was my experience. Like, if you have any thoughts on this, extruded feed.
Well, you have to, I mean, you have to make sure that there's a fair comparison to what you're doing. And, you know, as you're running a trial, I mean, first of all, you know, when I look at data, I look at what the trend of the data is, right? So you say at 12 weeks, there were no differences, but later on there were differences. Well, at 12 weeks, you should have been able to see that the data is splitting out. You should have been able to see the trend, you know, whether or not it's parallel or whether or not it's going away from each other. It's going away from each other. You need to think about how long that trial is being done.
Right.
But if it's running parallel, that's just them, you know, coming in and out of each other. And we see that all the time. I could run it to infinity and it probably is never going to have a difference if I keep everything the same.
Same, yes.
And that's quite often the difficulty is, you know, if you're dealing with a large, long growing period, the size of the pellet could be having an effect on what's going on in those animals. So again, you know, whether or not it's extruded, whether or not it's pelleted, whether or not it's lab-based, they all have different characteristics. You got to have a fair comparison when you're doing things. I don't know if that answered your question, but at least
just your opinion. Just your opinion, because sometimes we are running after idea. We need to have a lab skill extruder, and it costs like $200,000. You know, it's a big expense to set up a system.
Right, but it's, again, what are you trying to prove? If I'm looking at whether or not a temperature sensitive compound in the feed is going to go and work in the animal, and I'm adding it to the feed, well, there's a difference between going through a lab where the temperature gets to maybe 90 degrees for a few, minute, or
Right.
going through a pellet mill, which is going to get to 95 degrees for a long period of time, or it's going to go through a extruder and we're going to hit, 120, 160 degrees. Those are all temperature differences that are going to affect the performance. So
Right.
it just depends on what you're trying to look at,
Right.
and what those outcomes are. But to say, I have to have an industry size equipment to make a conclusion, I don't agree with that, because we've ran numerous times. So we'll have open feed formulations where we'll, have a mill, commercial mill, produce our feeds, and we'll get some mash from them, and we'll pellet it on our, lab pelleter, and we'll do a side-by-side growth trial. One's beautiful commercially produced pellet, and one's a lab-based pellet that falls apart after an hour or so. It doesn't look great, and we get the same growth performance because we kept the feed inputs the same, things like that. But so it all, like Albert said, it depends on what you're doing, but people have a tendency to say one thing or the other, and I just don't think that's appropriate. If I want to do a commercial grow out demonstration with an animal, I'm going to have to do that on a commercial size machine to get enough feed to do it. But scalable, most lab equipment is scalable up to certain sizes, and if you're below scalable, you're pretty close to what was done at the commercial level also. So yeah, there are differences.
Albert?
No, I agree with Alan. It depends whether we're talking about government funded, not government, or public research versus commercial. If you look at the commercial sector, the largest players, Skretting, Biomar, Alicorp, they all have their own mini feed mill, which is basically 1/50th of the size of their existing mill, so that the R&D work that they do related to feed processing is relevant. At the moment, maybe 95% of the feed that we produce for fish is extruded, whether it's because we can add more lipid or because it's better digestibility. So when industry does things, it wants to do things using the same processing, and I think, and I know that Alan in his lab, he has machines that can do cold pelleting, but also he has steam. He also can extrude his feeds as well if we need to. So it really depends on the quality of research. If I'm a company that sells enzymes, Kabir, I want to know if I put it in an extruder, if it's going to be there at the end. But so it all depends on what the aim of the research is.
And how you look at it as well. It's not only the enzyme, but how it is working on the animal or in the feed, right? That's what I always say, the feed meters, but because every enzyme can be different, right? Even different protease from different sources can be different characteristics. With different characteristics, can work differently on different raw materials, right? So the question is how this particular product working in my particular formulation in the raw materials I have. So this is very critical for the. Sorry, go ahead. You.
No, sure. So it's like. Sorry, Alan. No, but part of the future when it comes to extruded feeds is that we can basically make a feed, and then we top coat with things that are heat sensitive, whether it's an enzyme, whether it's a probiotic, whether it's a lipid. Do you understand? So it has obviously many advantages, but that type of R&D is very different from, it's very specific. But for the feed companies, it's very, very important. And that's why they've invested a lot of money into that equipment. It's not to throw money away, it's to, because even like Alan says, most of the improvements aren't necessarily with feed formulation, it's more with feed processing and feed management. But there's also R&D in feed processing.
Right.
whether it's grinding, whether it's conditioning, whether it's top coating. You know, each area has its own area
But what
of research.
Yeah.
if I just sorry, go ahead. Go ahead, Alan.
Yeah, one of the major things that aquaculture industry is lacking. I mean, there are few examples of scalable equipment, but even the poultry industry on a university type basis, there's only, I think, 3 poultry feed mills that are research-based poultry feed mills in the United States, if I have that correct, or if you want to include Kansas in there. There's Auburn, there's one in California, I think, and in Kansas, so there's 3. But in aquaculture, you know, there is no dedicated feed mill for aquaculture R&D in terms of, okay, he says there's one non-commercial.
No. It's just
What?
You want to say something? You finish.
no. I just want to answer to your question. No, it's good. It's important.
Anyways, you know, and that's one thing that we're lacking is that we don't have the you know, the feed milling, R&D and training of people as far as I'm concerned. Albert, you can comment on that if you.
No, I agree. It's like in Norway, you have Fortec. You have an institute which is designed just looking at feed processing
Right.
for the aquaculture sector. The sort of thing that Rick Barrows did before in the US within ARS. Really,
Right.
really important.
You know, the ARS lab, I'm not putting it down, and they got nice equipment,
Setup.
but it's not a scalable feed
Yeah.
mill, research feed mill.
Yep. I agree.
You know, and there's, you know, the protein center at Texas A&M, very good job at looking at things. Kansas State independently looking at things, but there's no real dedicated R&D, whether or not, you know, there are people who do it, but I can't point to, and I've never been to Norway, so I can't say that.
Sure.
Albert.
Sorry, Kabir. Now I'm going to put
No,
you
no.
in the hot seat.
No, go ahead.
It's like today, your boss in Jefo showed a new R&D facility
Right.
that they just opened for
In
poultry.
Right.
Beautiful facility, state of the art. You know, and my question was, yes, beautiful facility, but when are we going to have a similar facility for fish and shrimp?
Right.
No, again, because it depends on the companies and how much they want to invest in tomorrow,
Yes.
in the future.
Obviously.
And I think it's so important.
Right. This is very important to invest into good research, right? And how you do it and how much you want to invest into the research is also an important, right? It's also depends on the market size, right? The target market, or so everything, you know, like if you want to invest $1, you want to get at least $10 back, right? Because that's your $1 investment. Then you have to hire people, develop product, research on the product, lab research, and then you go in animal trials, right? It all adds up at the end, right? So if you have to bring a product to market, I guess it takes between 3 to 5 years from idea to market. And all these 3 years, 5 years, you're investing in product development, then marketing, you know, of the product. It all costs before you sell 1 kilo of the product.
Sure, but can I add one thing to that?
Yeah, sure.
And that is, you know, because you don't have your own R&D facility,
right.
You do your work with universities in China, in Vietnam, or in other countries, or including Auburn, you know, which has its advantages and it has its disadvantages depending on where you do it.
Right.
You know, that's all I'm saying. You know, in the case of Allen and Auburn, you've got one of the best, you know, facilities in the world, and you get really, really good results, meaningful results.
There are a few ways, if I may jump in. There are a few ways, basically. I talk with that. I'm not talking about the additive, but I'm talking about the feed now. Sometimes some companies, they don't have the R&D facility, right? Some feed millers, they don't have R&D facility. So what they have, reliable farmers, right? They are very close with those farmers. So they make a different feed and let the farmer use the feed, and they get the feedback from the farmers. So there are different ways you can test a product and bring up before you. But only thing is, when you want to convince the regulatory people, you need reliable data. When you want to market the product, you need scientific data. But whether it is working or not, you can test there are so many different ways you can test whether some ideas are working or not. Sorry to jump into that. If we have 10 minutes, but if I go to the next question, again, research related, we'll go somewhere else after this question. To Albert first.
No.
We talked about Alan talked about historical data, right? To be able to use historical data. So the question is, what are the standards, right? We need to put in place to be able to use the historical data, right? If we use water and then oil and then gel, we will not be able to compare between water and gel or water and oil. We have to be consistent, right? That this is my point, but if you have any opinion on that, right? How to effectively use the historical data, what are the precautions we should be taking to be able to use historical data?
I mean, it touches an important point. I mean, I think we have to do our homework. We have to do our due diligence. And that is not what only is published in aquaculture or aquaculture research or aquaculture nutrition, but also it's looking at the publications within the Chinese journals, the Indonesian, there's lots of information that's published that has abstracts that we can, we have to really look just not in things that are written in English, but also things that are written in Chinese and other languages. And, we don't need to reinvent the wheel. 60% of aquaculture production is produced by China. When China has their nutrition meeting, they have 2,000 scientists sat together,
right,
speaking in Chinese, publishing in Chinese, but all I'm just saying is that it's important that we capture that information as well.
Right.
So really that's the only point I wanted to make, that we have to, so for example, when I'm working with Alan and we work on cholesterol together or phytosterols, I do my homework first. I really try and look to see what's being published out there, what's good and what's not useful. But then, then we come up with an experimental design, to address a particular problem.
Alan?
Sorry, Alan, but yeah.
No, all of Albert's points are great, but I think my comment in terms of using historical data
was in-house.
If you don't have the details to make the comparison or not make the comparison, it's worthless. And so, we have lines of diets that might run for 5 or 6 years where it's taken from this base and then it's modified through time. But if I don't have the details of what the ingredients are and where they came from, like you're saying, gelatin versus this, I can't make that comparison. I need to know that it's apples and oranges, or if it's a Macintosh versus a Red Delicious versus a whatever. So it's just having those details to make those comparisons. But the genetics, even if we wanted to say that when I started doing research, 40 years ago, soybean meal wasn't the exact same thing it is today.
Today, right?
So everything changes. It's just a question of, did you give enough data, enough information to make a comparison? If I was going back and looking at my books for a business, I'd have the details of what I spent all that money on. We need the same level of details when we're dealing with nutrition and trying to, what do you need is important. That was my point, I think.
Albert?
And also to build on what Alan said before, that at the end of the day, what's really important is how you feed your fish or shrimp. Fish and shrimp don't feed 2 times or 3 times a day. So it depends whether it's to satiation, ad libitum, or a fixed feeding rate, because that will determine the result.
Beautiful.
And so at the end of the day, with chicken, we let the chicken decide when it wants to eat.
Yeah, beautiful,
In
beautiful answer.
aquaculture, it's dependent very much on the person that's giving the feed, and normally the person giving the feed has a minimum salary. You know, so like Alan said, you can make million variations on formulation, but at the end of the day, it's how we feed our animals that is also equally important.
Beautiful, Albert. It takes like it leads me nicely to the next question about seriously. It just happened about social structure Alan talked about, right? Uh, we have seen all the time. Alan talked about tilapia. I have seen in rainbow trout, right, as well. So the big ones, they come first, eat, and then when feeding is gone, like we see the huge size variations at harvest. But feeding frequency, increasing feeding frequency is a solution for that. Probably we know. I just want to draw an example before we go into the discussion. In Vietnam, in Pangasius farming, like when they reach 700 grams, they feed only once in 2 days. Right? Still, they have like less size variations. Whether is it feeding frequency or is it making sure that all the animals are fed? That was the kind of scenario.
The problem is it's many things and it depends on the species. We've got data on the Florida pompano. Feeding frequency clearly affects size variation in that species. If you look at, tilapia, size variation is actually more affected by social structure probably than feeding. So there's many things that happen, and you have to look at how things are going. But like your example, if you're only feeding every other day, and so there's reasons to cut back on feed for maintaining animals and whatnot. And I don't have an answer, maybe Albert does, but my philosophy is if I'm restricting the feed input, okay, and major restriction, then I would rather satiation feed 1 day, skip 3 days, than give them 25% ration for those 4 days. Because if I give them 25% ration for 4 days, the same quantity of feed, then the social structures demand who gets the feed.
Right.
Or at least that's the way I view it now. I don't think that there's a huge amount of data out there that, on what to do, but I think there's clearly enough that you're better off getting feed to everybody than to try and restrict feed where the small guys aren't going to get it, because that's just going to accelerate things.
I think what I've seen, I just Albert will take over. Just in Vietnam example, that probably they're feeding like for half an hour continuous, and those large ones comes in, they fill their stomach and then go away. The small ones have chance to eat. That's what I've seen in Vietnam, feeding every once in 2 days.
That same theory has been used in our catfish industry. They did a bunch of photo work where they looked at, videoing from above, and that I don't think that actually held true. You found lots of small animals feeding with the bigger animals, at least based on mouth size. But the overall result I agree with, okay? But it wasn't as clear as people like to promote it. But we put video cameras over ponds and had mixed classes, and then looked at mouth size to estimate the size of the fish. So,
Albert?
No, certainly many countries, they produce what they call a maintenance diet, which is like a 24-25% protein diet for tilapia, which is just basically to keep them ticking over. One of our future speakers for the webinar is Dave Robb, who now works for Cargill, I think. But before, when he worked with EWAS, which is now part of Cargill, we had a meeting in Manila in the Philippines on feed management, and he showed quite clearly that when you feed a cage from one particular point, you tend to get more competition. You get more bigger size fish, and then you get the weaker ones that find it more difficult to feed. And so obviously, the better you are able to distribute the feed within the cage, the less competition you will have. But certainly there's a trend out there for the production of a maintenance diet, which is basically a diet where the farmer can just hold the feed can hold the fish before they sell them. Sorry.
So we are almost at the end of our session, but we have just one more question. Okay, this is about attractants. There was a slide about attractants, right? On attractants, and as we know, as first word, I think Alan put like Dr. Chowdhury's one paper, 2011 paper, also another one published in Global Aquaculture Advocate in I think 2003. So my question is about, like I saw feed miller, right? They're putting fish meal or fish oil or squid meal, and farmers like the smell, because this like we know that farmers, fish is not smelling anything, but farmers like the fishy smell. We are trying to appeasing the farmers, not the animal, right? So coming to the like two sides of attractant, with the real attractant or attracting the human, not the animal.
A lot of the times what we're doing is
question.
we're attracting the human. It's perfume. What I tell farmers and people who want to talk about attractants is, when they smell it, I said, well, that's not what the animal smells. Stick your head in the water, then smell it. And unless you do that, you're not going to understand. Attractants have, a lot of times what we are doing is appeasing the farmer for color, for smell. There's lots of things that are done just for the farmer that have absolutely nothing to do with nutrition. Attractants and palatability enhancers do work to a certain extent. I'm not saying they don't, but I'm just saying that a lot of times we're exactly right. You're doing something for the farmer, and we really don't know if what we smell is what the animal's going to respond to, in my opinion. So,
Albert
stuck his head in the water and smelled what the fish and shrimp smell like.
I'm always sticking my head in the water somewhere. No, I mean, when it comes to shrimp, attractants are really important. The faster we can get the shrimp to eat the feed, and the less time the feed is in the water leaching nutrients, the better. So obviously, but sometimes just sticking fish oil on the outside of the pellet works just as well, in that it works as an attractant, but also reduces the leaching of the water-soluble nutrients. So it depends on the species, but for species that feed slowly, like crustaceans, yes, they are quite important.
Thank you, Albert, and thank you, Alan, to be here today. We're almost at the end of our session. You will find today's PowerPoint in PDF format in the handout section, and also two papers on attractants, because I mentioned in the chat box. Thank you all again, and thank you, Alan. Thank you, Albert, and thank you, Annie. Annie can show your face if you want to, but otherwise it's okay. Yes, all of us are here, and we will meet probably early next month for the next session. And thank you, Alan, so much it was really wonderful and an eye-opener. And Albert,
thank you.
Thank you all, and thank you all to be here and to listen to the show, I say, and then you can watch this in Jefo YouTube channel as well within the next few days. So tune in and click on the video, right? And we'll all learn and then work together to get something to take the industry one step ahead. Thank you again. Thank you all. Have a good night.
Thank you.
Or good evening. Good morning. Bye bye.
Ciao.
Good night. God bless. Bye bye.
Bye.